This is First Coast Math Clinic with Lesson 3, Multiplying Polynomials from Unit 12, Polynomials from our Pre-algebra and Algebra curriculum. So the goal in this video is to perform multiplication on monomials and polynomials. So we're going to start with polynomials that have just one term and multiply them by polynomials that have multiple terms. And using FOIL to multiply binomials. So I'm going to show you how to multiply binomials. We're going to use FOIL, and we're also going to use the box method to multiply binomials. So I'm going to show you two different ways to multiply binomials. So let's get into our first example where we multiply a pair of binomials. So here we've got 5x squared times 4x to the third. So when we multiply this, we want to multiply our coefficients, so the 5 and the 4. And we're going to multiply the variables, the 2x and the 3x. So 5 times 4 and x to the second, x to the second and x to the third. So 5 times 4 is 20. Now when we multiply x to the second times x to the third, we've got the product of powers. So we're going to keep our base. We have the same base, so we're going to keep the base and add the exponents. So this is going to give us x to the fifth power. So we have 20x to the fifth power here. For the next example, we've got 3x squared times 7x to the fifth plus 9x. So here we're going to distribute the 3x squared inside the parentheses. So we're going to have 3x squared times 7x to the fifth plus 9x times 3x squared. So we can multiply our 3 times 7, and then our x to the second times x to the fifth, and then our 9 times 3, and then our x times x to the second. 3 times 7 is 21, and then x to the second times x to the fifth. We're going to keep our base. When we multiply two terms with the same base, we're going to add the exponents. So this is going to be x to the seventh plus 9 times 3 is 27. Then we have x times x to the second. We don't have a visible exponent here, so we know this is x to the first. We have the same base, so we're going to add our exponent. So this is going to be 27x to the third. And now at this step, we don't have like terms. They have the same variable, but different exponents. So these are not like terms. So at this step, we're finished for number 2. And for number 3, we've got 2/3 x y to the third times 18x squared y plus 1/2 x to the fourth y to the fourth minus 12. So we're going to do the same, use the same distributive property. So I'll multiply 2/3 x y to the third times 18 x squared y plus 1/2 x to the fourth y to the fourth times 2/3 x y to the third minus 12 times 2/3 x y to the third. All right, so now I want to rewrite this grouping the terms together that I'm going to multiply. So I'm going to erase this next step, give myself a little more room down here. So here I'm going to multiply 2/3 times, I'll put the 18 over 1, and then x times x squared, and then y to the third times y. So I multiply the 2/3 and the 18, this x and x squared, and this y to the third and this y. And now 1/2 times 2/3, and then x to the fourth times x times, not 4, should be y. Y to the fourth times y to the third. And here we just have minus 12, so this could be minus 12. I'll put that over 1 times 2/3 x y to the third. Squeeze that in there. Okay. All right, so let's go left to right and multiply this. 2/3 times 18 over 1 is going to give me 36 over 3. X to the first times x to the second is going to give me x to the third. Y to the third times y to the first is going to give me y to the fourth, plus 1/2 times 2/3. So again, when I multiply these fractions, I'm just multiplying straight across, straight across, straight across, and straight across. I'll get 2/6 x to the fourth times x to the first. I'm adding my exponent. It's going to give me x to the fifth. Y to the fourth times y to the third is going to give me y to the seventh. Minus, now again, multiply straight across. 12 times 2, 1 times 3. So I'll get 24 over 3 x y to the third. Now we can simplify our fractions. 36 divided by 3 gives me 12 x to the third y to the fourth, plus 2 over 6 simplifies to 1/3 x to the fifth y to the seventh, minus 24 divided by 3 is going to be 8x y to the third. And at this step, all my variables and exponents, my variables are the same, but the exponents are different. X to the third, y to the fourth, x to the fifth, y to the seventh, x, y to the third. So at this step, we don't have any other like terms, so our answer here is finished, and this is going to be our final answer for number 3. All right, let's get into some examples where we multiply binomials. All right, let's multiply the binomials 3x plus 2 times 4x plus 5. Now, there's a couple ways that we could do this. We can multiply this the same way we were multiplying the polynomials on the previous slide, and multiply like 3x plus 2 times 4x, kind of do like distribute this entire quantity, and multiply like 3x plus 2 times 4, and then 5 times 3x plus 2. There's another way to do this though, and I'm going to show you an easier way to multiply binomials. And I'm going to show you actually 2 different methods to multiply binomials. And the first method is known as FOIL. And what FOIL stands for is first, outer, inner, and last. So we're going to multiply our terms in that order, starting with the first term, outer term, inner term, and last term. So let's do first term. So our first term is going to be 3x and 4x. So 3x times 4x. Outer. So the outermost terms are 3x and 5. So 3x times 5. Our inner is going to be the innermost terms in the parentheses, so 2 and 4x. Then the last term, so the last terms in the parentheses, 2 times 5. Now we're going to multiply these. So starting again with our first terms, 3x times 4x. So 3x times 4x is going to give us 12x squared. Now our outer terms, 3x plus 5, or excuse me, 3x times 5. 3x times 5 is going to give us 15x. Our inner terms, 2 and 4x. 2 times 4x is going to give us 8x. And then the last terms, 2 times 5, will give us 10. Now from here, we can identify our like terms. So our like terms, remember, have the same variable raised to the same power. So that's going to be the results of our outer and inner terms here. So the 15x and 8x, we can add these up, and we're going to get 12x squared plus 23x plus 10. So this is going to be our quadratic trinomial that we get when we multiply 3x plus 2 times 4x plus 5. So that's using FOIL, first, outer, inner, last. There's another method that we could use to multiply these binomials, and that is the box method. So let me show you the box method as well. So for the box method, I'm going to draw, we said a box, and I'm going to break the box up into 4 squares. And our multiplication is multiplying 3x plus 2 times 4x plus 5. So basically what we have is we've got 1, 2, 3, 4 spaces along the sides of the box. I'm going to fill in each one of these spaces with a term from our binomial. So this first term is going to be 3x. So this is going to be from like right here. So then this space right here has to be that positive 2. So that's going to be plus 2. This term then has to be that 4x. So then this term has to be the positive 5. All right, I'm just adding the plus sign in. You don't have to add it in if it's positive. So now all we're going to do is go down and across and multiply our terms. So 3x and 4x down 2 and across 4x. So if we can write this a little neater. So I'll bring that 4x all the way across. Bring the 3x all the way down. And then 5. And then I'll bring the 2 all the way down. And I'll bring the 5 all the way across. And if you notice, we have the exact same multiplication that we did here when we did first, outer, inner, last. It's kind of like how you prefer to visualize what the multiplication is, right? So 3x times 4x is going to give us 12x squared. Let me get rid of these lines so it's a little bit easier to see. So this is going to be 12x squared. Four x times 2 is going to give me 8x. 5 times 2 is going to give me 10. And then 5 times 3x is going to give me 15x. So we notice here, diagonally, we've got our like terms, 15 and 8x. Going to add those up, and we're going to get 23x. So we get 12x squared from this top left corner, 10 from the bottom right corner. And I'm going to actually, just to show all of the work done out, I'm just going to add these here just so we can see what's happening. And then, all right, same thing we had here. So let's add our like terms, and we get 12x squared plus 23x plus 10. So we get the same answer both ways using FOIL and using the box method. Okay. Again, it kind of depends on, it's your preference basically. Do you like FOIL? Do you like the box method? It's kind of up to you. All right. Let's get into a couple more examples where we multiply binomials using either FOIL or box method. right, so let's multiply the binomials for number 1 and 2. So for number 1, we're going to use FOIL. So first set of terms are going to be 5x and 2x. Outer are going to be 5x and minus 3. So when I do this, I'm making sure to include the sign. So I have to include the minus sign with the 3. Inner is going to be 7 and 2x. And then last is going to be 7 and minus 3. Actually, let me write it the other way. I'll start with the negative or minus 3. All right, so now let's multiply these. 5x times 2x is going to give me 10x squared. Minus 3, or negative 3 times 5x is going to give me negative 15x. 7 times 2x is going to give me positive 14x. And then minus or negative 3 times 7 is going to give me negative 21. Now our like terms are going to be in the middle here in the outer and inner terms. Negative 15 plus 14 is going to give me negative 1x minus 21. Into this step, that's going to be our final answer. All right, for number 2, let's use the box method. So draw out our box. I'm going to have negative 2y and negative 4. So I've got to include the sign with my term. So I'm including the negative 2y, the minus sign with the 2, and the minus sign with the 4. And then y and minus 9. So y is here, and the minus 9 is here. Okay. All right, so let's multiply this. We're going to go down and across. So we're going to have negative 2y times y, down and across. So this is going to be negative 4 times y. Go down, and actually do this one. Go down and across. So this is going to be negative 9 times negative 2y. And then go down and across. Negative 9 times negative 4. So in this top left square, we're going to get negative 2y squared. Top left, top right, we're going to get negative 4y. Bottom right, we're going to get positive 36. Right, negative times a negative is a positive. Whenever I multiply or divide, two numbers that are the same sign of the answer is going to be positive. And bottom left, negative 9 times negative 2 is going to be positive 18 and positive 18y. Okay. Now we notice that our like terms are here and here. So let's write this out. Negative 2y squared plus 18y minus 4y plus 36. Again, our like terms are right here. We get negative 2y squared plus 14y, 18 minus 4, plus 36, and this is going to be our answer. All right, let's do two more examples of multiplying binomials where we use FOIL and we use the box method. All right, so for number 3, let's use FOIL. So first, Let's do 3x squared times 5x squared. Outer 3x squared times minus 2y. So again, we're including the sign with the 2y. So I'll have minus 2y times 3x squared. Inner is going to be 7y times 5x squared. Do this in the same color. And then last, (7y) times negative 2y. All right, so combining our like terms, 3x squared times 5x squared is going to give me 15x to the fourth. Multiply our bases. We want to add our exponents. Outer negative 2y times 3x squared is going to give me negative 6x squared y. Inner 7y times 5x squared is going to give me positive 35x squared y. And then last, negative 2y times 7y is going to give me negative 14y to the second power. All right, now we notice our like terms are here, same power raised to the same exponent, x to the second power, y to the first power. So our last step, we get 15x to the fourth plus 29x squared y minus 14y squared. Negative 6 plus 35 is going to give us positive 29. All right, and this is going to be our final answer. All right, let's do one more example where we use the box method. All right, so here we've got negative 2m to the third minus 3n squared times negative m to the third minus 5n to the second. So for our box method, let's draw our box with our four squares inside. And along the top, I'm going to start with negative 2m to the third, negative 3n squared. So remember, we've got to include the sign. So my negative 2m to the third is here. Negative 3n to the second is here. So then this is going to be negative m to the third, negative 5n to the second. All right, so now we're going to multiply down and across. So negative 2m to the third times negative m to the third, down and across, negative 3n squared times negative m to the third, down and across, negative 2m to the third times negative 5n to the second, and then down and across, negative 5n to the second times negative 3n to the second. All right, so multiplying this out, we've got a negative times a negative, so our answer is going to be positive. We're going to get positive 2m to the third times m to the third is going to give us m to the sixth. We're going to add our exponents. Here we've got a negative, top right, we've got a negative times a negative, so it's going to give us a positive. So we're going to get positive 3. And this is going to be n to the second times m to the third. We can't multiply those, so it's just going to be n to the second, m to the third. Bottom left, negative 2 times negative 5 is positive 10. M to the third, n to the second. We can't multiply those, so we're just going to keep it n to the second, m to the third. And bottom right, negative 5 times negative 3 is going to give us positive 15. N to the second times n to the second is going to give us n to the fourth. Multiplying our bases, we're going to add our exponents. All right, so we've got our 4 terms here. Let's write this out. 2m to the 6th plus 3n squared m to the third plus 10n squared m to the third plus 15 n to the fourth. All right, so now our like terms, we've got n to the second, m to the third, n to the second, m to the third, so our like terms are going to be right here. So I'm going to bring down the 2, m to the 6th, 3 plus 10 is going to give us 13, n to the second, m to the third, plus 15, n to the fourth, and this is going to be our final answer for multiplying our binomials, okay? All right, so this video was lesson 3, multiplying polynomials, and we went through specifically how to multiply monomials by polynomials and how to multiply binomials using FOIL and using the box method. Hope this video helped you guys. If you like this video, leave a like, comment, and subscribe. If you want to see some additional topics, leave the topics in the comments. Again, if you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.